So it is recording. Okay, so today so last time we went over the file system. Questions on the file system. Questions on the material file, yeah.
Could you redefine absolute and relative path again?
Sure. So the definition is simple, but kind of deceptively so. Let's see, where did I? So basically absolute paths are a path that starts with a forward slash. And other paths that don't start with a forward slash are relative paths. That's basically it. But the context of this is that if it starts with a slash, that's the root of the file tree. And if it's the root of the file tree, that means the absolute path has every directory you need to enter in order to reach that file. Relative paths are relative to the current working directory. So every process has a record of the current working directory, the current directory you're in, like if you're in your bash terminal and you type dir or you type ls or you type pwd, that's all relative to your current directory. Does that clear it up? I think there was a question over here. Okay, no? Yeah.
So what would be like a difference between like /bin, ./bin, and just bin? In terms of like the homework? Like,
So in terms of the homework 2?
Yeah.
Okay, yeah. How about we just go over homework 2? Let's go over homework 2. So you're asking about the difference between bin, ./bin, and maybe /bin as well?
Yeah.
Okay. So let's start with the two of these. So let's say I say ls, and I'm going to just comment this out. ls/bin versus ls./bin. All right. So first of all, this what kind of path is this? Is this relative or absolute?
Absolute.
It's absolute. So where in the file tree does this bin directory live? In the root. In the root. So if I list the root directory, so this is actually on Eustace. If I list the root directory, you can see under the root directory, the / is the root directory. There's a bin directory here. And so if I say /bin, well, just for some context, I'm currently in my home folder here. So if I say ls/bin, that's the bin folder under the root directory. To show this as a tree, remember the root of the tree always starts with the root folder, and that means there's a subdirectory under the root directory called bin. A dev above bin? Boot? So that's boot. This is a different directory. Do you mean this /dev?
I'm just confused. It's like the working directory /dev.
I see what you mean. Yeah. Okay. That was kind of a trick question a little bit. All right. Let me just go over the homework, and hopefully this homework will make it clear. Okay. So if my working directory is /, we know that we're always going to have a / folder as the root, and I have an absolute path here. So this is an absolute path. What's the parent folder of home? Root. It's /. This is an absolute path, and the only path above it is the root folder. So where on this tree does home go? It's just right under the root. All right. Similarly, if my working directory is still the root, and my absolute path is /dev, where on this tree does dev go? Under the root. Because it's an absolute path, it starts from the root folder. We know this is a child of the root folder. Now here's the trick question. My working directory is dev, so I'm currently here. I think I denoted this with orange or something. So say my working directory is here, and I have, what kind of path is this, absolute or relative? Absolute. So where on this tree does boot go? Does it go under dev, or does it go under home, or does it go under root?
Under dev.
Who says dev? Who says root? So, so for dev, why does it go under dev? Yeah.
You're right. if you're having the path absolute path bits, then wouldn't that mean you're going to be already the dev folder that you're in loop, and a slash is basically
So you're getting there. So the kind of key trick here is that for absolute paths, the working directory is irrelevant. So because it's an absolute path, it tells us all of the subdirectories you need to enter in order to get to boot. So in other words, if it's an absolute path, the the working directory doesn't matter. That's the key trick here. Yeah. Because I just tell you it's the working. Yeah, it's here.
Oh, that's how it's supposed to know?
Yeah, this is what we're working directory. Yeah. So this is the current working directory. And so the main punchline here is that no matter what your working directory is, if you're given an absolute path, then the working directory is not even taken into account. The working directory only is used when you have a relative path to figure out from where, relative to the relative path, you need to go in order to find this file. Questions on that? Yeah. Sure. Yeah. So boot is an absolute path. So for basically all the absolute paths, you can ignore the working directory. The working directory, and I made them slash to make it like less confusing for the first couple, and then made one that was a different working directory. But for absolute paths, the working directory is irrelevant to finding the file. So just like for these other two absolute paths that were children of the root directory, boot is also a child of the root directory. Questions on this? Questions? Okay, so now for the next one, I'm saying my working directory is root. So let me put this orange here for the working directory. And now I've got a relative path relative to the working directory root. Where on this tree does user go? Under root, because this is a relative path. So in order to know which path to start from, I look at the working directory. My working directory is slash. You can also think of this as concatenating this working directory with the path. You could kind of glue this before the path. You need, with appropriate directory spacing. But okay, this path is also, or this folder is also under root. Okay, so now let's look at the. So questions on that one? Yeah.
Can I just go back to why boot is under the working directory of the root and not dev?
So for that one, the working directory was dev. But because absolute paths the path description always starts from the root directory, the working directory is not taken into account for the absolute path. So if you give the absolute path on the command line, then the working directory is irrelevant to that path because you already have the.
So is that kind of like there to throw you off?
Yeah, this was a little trick for you, but when actually using the system, so I'm in my home folder here. But if I want to look at everything in some root folder, I don't want to have to do a relative path down to or I could, but it's more expedient if I just list everything in the root bin directory, which I can do if I like. I'll just list everything in the root bin directory, and I don't want to have to take into account my working directory. I just want to refer to some file without taking into account the working directory, so I can use the absolute path. Does that?
But it would be necessary to take into account the working directory and for some reason have the same file under another working directory.
Not if it's an absolute path, then you never need the working directory. The absolute path gives you the it gives you a unique file, basically. It's a unique file without any relative paths. Yeah.
Do you need the dots and the two dots after each path or whatever
You don't need to, but because so for instance, you can put as many dot paths as you want because it's just a cycle that refers to itself. So you're not going to change what file you're referring to.
No, in the tree, or is it the same?
Oh, You don't. If you put them in the tree, great. If you didn't, that's okay for the homework. Yeah, it's okay.
Okay.
Yeah,
So combining the working directory with the path always gives you the absolute path.
yeah, that's right. Yeah, yeah. And there's you can actually do this on the command line. Well, yeah, you can there's a tool called readlink -f. I don't remember why it's -f, but so you could give it some complicated relative path, and it will. I think that doesn't exist, and it'll kind of turn it into the absolute path. It's like a bash scripting trick. Other questions on absolute versus relative? I'm glad we're going over this so you can kind of work out the kinks in your understanding. All right, so let's finish up a couple more of these. All right, so if I have the path Paul, it's relative, and my working directory is home. So let's move this working directory to home. Where on the tree does the Paul directory go? So, who says under home? Who says under root? Who says under boot? All right, good. Yeah, it goes under home. All right, let's do this. Let's do this complicated one here. .home, /home /Paul /source. Is this relative or absolute?
Relative.
How do you know it's relative? It says it, and it doesn't start with this doesn't start with a slash. And my working directory is dev now. Yeah. What's your question?
Maybe we should color code slash and make the relative one like the dotted one. That's what I did, just so you can tell the difference between absolute and relative.
You can. You could use / always to tell yourself, well, this is relative. But and at least in the convention, you don't have to on the command line. For instance, I can refer to the hello directory without the /. Okay, so I've got my working directory is dev, and my path is /home /Paul /source. So what's the name of the file here? That's the file name, not the path to it, but the name of the file. Yeah, source, src is the name of the file here. So source is somewhere on this tree. So how can we find where on the tree this directory lives? You follow the path. So we start from the working directory. This is relative. The .. directory, what directory are we in now if we follow the .. path length? Say again? Root. We're in root. So every directory has a .. directory, which I didn't draw here, but I can draw it to show you. And that has a hard link to its parent. That way, when we follow the .. path, we are now in the root directory. So what's the next directory in this path? Home. So that tells us to go to this directory. We're currently in this directory. The next path here is what? It's Paul. So we're here. And now we have the actual name of the file, src. So what directory is the src directory under for this path? Under Paul. All right, questions on... Let me do two more to get the bin and /. All right, so let's move our working directory to user now. And we have a relative path bin. So where does the bin file live? In user. So there's a bin file here in user. And let's move our working directory to home /Paul. And we also have a bin file here. So let's follow the path. There is a .directory in every directory that has a hard link to the directory itself. So when we follow dot, we're still in the Paul directory. And then bin is referring to a child of Paul. So this bin here It's not different because it's // it's different because the working directory is different. Yeah. The first bin? The first bin was in a different working directory. So it's in the user working directory. That's why that bin is under user. All right, I think this is making things clear. Hopefully this is making things clear. That's why I try to design the homework like this. Questions? Other questions on this? Yeah.
I'm just not sure if maybe this is the same question, but I don't understand like how the mash home call source path isn't underneath the dev working.
Okay. So let's go back to this example. So the reason is because of the .. directory. The .. direct, every directory enforced by the operating system, every directory has a .. like, so each one of these directories has a .. folder in it. That .. folder points to the like for dev, for instance, it has a .. folder. It points to dev's parent. Dev's parent is root. So as soon as you have a path that says .. you are referring to the parent of the current directory, whatever that is. So now that we're referring to the parent of the current directory, if we look at the rest of the path is this. So since that .. puts us into the root directory, the rest of the path is from the root. And following each element of the path, we get home, Paul, source. Okay, other questions on this? Yeah.
Do we have to like specify the dots and the dots in the homework?
No, you don't have to put them. I didn't ask for them, so they're technically always there in a I guess POSIX style operating system. They're always going to be there on every file tree. But no, you didn't have to put them. I didn't think to require you to put them. All right, I hope that clears it up. And I hope this helps you know where your files are, particularly from the command line. And today, knowing this, we're going to start seeing how to use common command line utilities to move around, navigate, and modify the file system. And knowing the difference between these paths, knowing how to refer to files, is essential for doing that. Just as essential is also knowing that there is a working directory and keeping track of it. And also, I'll show you tools for actually viewing the current working directory. So basically, tools that you can use to just never get lost. So for instance, whenever I open up a command line terminal, I'm always just running, where am I, what's here, constantly, just to stay aware of where I am in the file system. Okay, so let's go over today's lecture. So it's mostly going to be practical, just showing how to use the command line. Yeah.
Sorry, I had a question
Sure.
about the very last working directory.
Oh, yeah.
It ends with a slash, whereas none of the other working directories end with a slash. Does that make any difference?
Oh, yeah, that's a good question. No, no, it doesn't. It's so to refer to the working directory, I use a path. No, it doesn't. It doesn't. There are places where slash versus not slash may make a difference. I'm thinking an rsync tool maybe, but effectively no. You can think of all directories as like implicitly having a slash after it. That's not part of the name. But yeah, it shouldn't make a difference for this example. Okay. So actually using the command line, putting this file system kind of theory into practice. Yeah.
This little code in our homework assignment 3.
I'll go over homework assignment 3 in due time. I will go over homework assignment 3. There won't be coding. It'll just be using the commands that you learned today, if you haven't seen it before, to accomplish the task. So to not leave everyone in suspense.
I'll read along with you so that we could have how do we submit it on web? I don't always want to submit on web courses, but
So
submit as a file or is it like a PDF?
you can just submit text. It'll just be a series of text commands. This is one of the beauties of using the command line is everything is just text. And so there's no need for screenshots or pictures. You can just cut and paste text. So it'll just be a sequence of bash commands. So these are just text, so you don't need to take a picture. You can just submit the sequences of commands. And just as a little preview, for homework today, I've given you a tree that you can download, that you can download and unpack, and you'll have your a file system hierarchy on your Eustace account. And then as a little kind of puzzle solving exercise, I've given you the tree that I'd like you to make out of this this one here. There's lots and lots of ways to do it. If you want to challenge yourself, find the minimum way or the optimal way or something. But just using the commands that we go today, turn this file tree into this file tree. And it can be done with a finite sequence of
Oh my God,
commands.
I'm scared. What if it's hard? Is it easy or is it hard?
Depends on whether you've done it before. It might be a little puzzle solving, but it shouldn't be too bad. Don't spend more than an hour on it, I would say.
But I'm scared.
That's good. Use that fear to motivate you to get excited about the project. There's nothing scary here. Okay, so you can certainly follow along with this. Hopefully everyone is set up with Eustace. If not, be sure to get yourself set up, be able to make sure you can log into Eustace. Talking to Denise in CECS, everyone in the course should be added to Eustace now, should have access to it. This is how you log into Eustace. You put, once you have your system set up for SSH, sure, the terminal, right? Oh, and actually, let me, the color is, let me make it, that should be easier to see. Is that better? Is that size good? Okay. So put your NID, put your NID and then eustace.ccs.ucf.edu. Oops. Why is that not right? Oh, thanks. Oh, it's ECS. Uh-oh. Thank you. Let me fix that. ECS, thank you. Okay, so ECS, and then you'll have to enter your password. I set up an SSH key. If you'd like to do that, there is a guide on the webpage, on the syllabus webpage for doing that. So you don't have to type your password every time. But okay, so then you should be presented with a prompt that looks like this, except for with your username. One little trick that I actually probably should have put in here. Control L will clear your screen. I should probably add that in here. It's kind of a habit I do all the time that I forget about. So instead of typing the words clear, you can just do Control L. Hold down Control and hit L. So there's a lot of these commands, both in the editor. One of the editors I'll show you. That'll clear your screen. Okay. So hopefully you're all in Eustace. If you have any issues with Eustace, let me know. You can also reach out to CECS. Yeah. No, these are like, I think everything I'll show you is, will be available, I think, on all Unix installations. Just about all Unix installations will have these commands. So you'll be able to sit down at a Mac, like BSD, Linux, pretty much any distribution, and you'll be able to use that machine. So Windows has, I think, PowerShell. So I haven't used Windows but I think it has some of the Unix commands in it. Correct me if I'm wrong, anyone?
They're not the same.
They're not the same. You can use, Windows Subsystem for Linux. You can use that if you want to use Windows to have these commands available. But you have SSH. But yeah, for a Unix style installation, I think these are actually like part of the Unix standard. So they're supposed to be there for any Unix installation. No problem. Yeah, they're not. I don't think there's anything here that's used to specific. I think nothing that I'll show you will be used to specific, including the Git and homework submission. That'll also be, usable elsewhere. Okay. So running commands is pretty straightforward. You just type the name of a command and hit enter. But, it doesn't really tell you what commands to run, right? It's a little esoteric. It's just some text and a box. So, you can freely type things. So to see, since, the current working directory is so essential to figuring out where files are on your path, one of the first commands I show you is pwd, print working directory. That's what it stands for if you want to try to remember it. So type pwd and hit enter, and voila, it gives you what kind of path is this? Relative or absolute? An absolute path. It's an absolute path. When you first log in, you'll be in your home directory, which is space allocated to you for reading and writing files. So that's print working directory. I type this all the time just to remember where I am. Many shells are set up to tell you what directory you're in on the prompt. So for instance, this is telling me I'm in tilde/hello. And tilde is like a special syntax for your home directory. So there's this home directory is allocated to you by the system administrator, and there's just a shortcut to referring to your home directory, tilde. That's all that means. So when I'm in my home directory, when I first log in, it's going to say tilde. That just means you're in your home directory. Okay, so pwd to see the absolute path to where you are. And if you want to see what's in the directory, you type ls. So I've got all sorts of random stuff here. ls, you can remember list. Yeah. No, it might actually be empty. If you want to confirm that there's stuff actually there, you can do ls-a. That shows hidden files and folders, including your dot and dot folders. But yeah, you probably won't have any. Yeah, you may not have anything there if you've never used Eustace. Excuse me, but we'll make some stuff. Okay, so that's where are we? pwd print working directory, pwd print working directory, and what's here? ls list. Yeah.
What about LL? Is that the same as LS?
LL is an alias for an ls command. So I'll show you this right here. So LL is just the same as running this. These we'll talk about this, I think, next time related, but these are options that you can use to alter the behavior of a command. So LL will, yeah, so don't worry about LL, but you can use it if you want to use it, but it's just a alias to an ls variant. All right, so where are we? And what's here? I probably type this like hundreds of times a day. Okay, so running commands with arguments, you just, so ls, for instance, if you run it by itself, it'll just list the current working directory. So this notion of a current working directory pervades like all of these tools, the notion of a working directory. If you instead provide a name after it, so an argument to the command, arguments are command specific. Oops. If I provide an argument, then it'll instead list the directory that I provided at that path. So where is this hello? Which folder? What's the parent folder for this hello folder? So what kind of path is hello? So if I say hello, what kind of path is this? Relative. Relative to what? Working directory. How do I know the working directory? pwd. So what's the full path of hello? Exactly, yeah. Home net, my home directory, followed by hello. I saw a question. Was a question? Yeah.
Like, you have to log out of this. I don't know, it's gonna
Yeah, you can log out. You can type exit to log out. Yeah. Type exit or Control D will also exit.
So if you close the terminal, is that just
Yeah, if you close the terminal, it'll kill the process, and I think your connection will eventually get. Yeah, we'll get killed. Okay, so that's running commands with arguments. The arguments are command dependent. You can always type man for manual with an argument as its argument you can give as for its argument a name of a command, among other things, and it'll be this nice description of all the options that you can use. Q to quit. It might be a confusing interface. Yeah.
So I'm looking here, like putting in like a password for Eustace, so like it automatically does it. Do we have to be logged into Eustace the first time and then run that command
to avoid having to run a password?
Yeah.
Look at the guide on my page for using SSH keys, and that'll get you there to do that. Okay. Yeah, there's nothing. You have to do something else. You have to make an encryption key or a digital signing key, but it'll go through that to avoid doing that. Okay, so that's using arguments. You just put a space and then the name of the argument, and it's command dependent. Each command interprets arguments differently, but the shell will pass those commands to the program. Okay, so CD, change directory. This is how we can change our working directory. So for instance, I'm going to change to /user/include, which might sound familiar. Does anybody know what this path usually contains? Yeah. Yeah, it contains C header files or system-wide C header files. So we've got where am I, what's here with ls, and CD will change the working directory. So now if I then try to list hello, well, it's not here. That was in my home folder. What happens if I do cd /? Where do I go? Nowhere. Same working directory because I'm referring to the same working directory. You can see the working directory stays the same. All right, and here's where more relative paths are useful. So if I want to get back to the parent directory, then I always have a reference to it. There's nothing in this folder that tells me what the parent directory is except this special ... folder. So if I run this, what's my working directory going to be if I change directory to ... User, good, yeah, it's going to be the parent. And I can confirm that with print working directory. Can see what's here. This is what's here in the user folder, user directory. Questions on this? Pretty straightforward, right? So you already know enough commands to kind of explore your file system and look at basically every file you want on your file system. Yeah.
So I try to like go try like download the home of CAR, but it won't like but it's not it got like this like we're resolving blah 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 blah, and it won't like I don't know, I'm confused.
It's hard to see because I can't see your machine, but yeah, come to office hours tomorrow when I have office hours, or take a look at the video. So you should be able to type pwd ls and type / change directory space / usr / include. And when you type pwd here, also make sure you're in Eustace. Make sure you're logged into Eustace.
Yeah.
So we can go over it in office hours if you come to office hours. All right, so where I'd gone up to before was using this parent path, this relative path, to go to the parent directory. What if I'm in user include and I type change directory ... /user or ... include? Where do I go? Yeah. What's that? Huh? Yeah, include the same directory I'm already in. So running this leaves me in the same directory. All right. Okay, so it's really tedious to type all this all the time, type paths all the time. So I'm going to show you a couple of tricks for making the command line fast. These are really indispensable for me. I probably use these, I don't know, hundreds, thousands of times a day when I'm doing classes or doing development or anything. These are the main tricks that I want everyone to know that you will make. It'll be much less of a headache to work on the command line if you learn these tricks. So you're probably typing a lot of stuff and you're seeing that it looks like I'm typing really quickly. But actually there's a couple of tricks, tools really, that the command line gives you, that the bash, the shell gives you to make this stuff really fast. And one of the most useful things, if you forget everything and forget about the command line, take one thing away, is tab completion. And it works for files, folders, and also command line arguments. And so this is, if you remember, I talked about the 3 virtues of a great programmer. One of them is impatience. So if you're trying to sitting there typing for seconds and minutes, You should be very impatient and be like, this really is painful. I don't want to have to do this. It also satisfies laziness, because this tab completion will make it so you don't have to remember what files are there. It'll kind of help you interactively explore your file system. Okay, so let's look at an example here. So let's go back into this user/include directory. So where am I? What's here? I'm in the user/include directory. So try this at home if you don't have your machine in front of you. But before you type enter, start typing a file and hit the tab key. You can't see what I'm doing, but I'm hitting the tab key. And it'll automatically fill out the rest of the file name for you. So let me show that again. So I'm just hitting one key right now, and it's typing out the entire file for me. Isn't that amazing? All right, it looks like nothing up here, but when you actually go to use it, it makes you very, very fast exploring files on the command line. For some tasks, much faster than, say, a file explorer. Yeah? Aha, very good question. So what if this carefully selected GNUM prefix is not the only, that yields multiple files? Very good question. So what will happen is, let's say I type GNU and I hit tab. The first time I hit tab, nothing happens. You hit tab again, and it shows you all the possible files that have the same prefix. So you can see that, so let me list the whole directory here. The whole directory is very long. There's, hundreds of header files in here and subdirectories. But if you hit tab a couple of times, hit tab twice, it'll show you only those files that match the prefix that you've written. And so now if I continue typing, I don't have to type out GNU versions. I can type another character, hit tab again, and once you get a unique prefix, it will fill out the entire path for you. So for instance, if I'm trying to write an absolute path, I'll just kind of obsessively and habitually type tab all the time. So if I want to type the whole path, I only need to type a couple of characters. So to do this slowly, I only need to type U and IN, tab, for this to fill out the path for me. So much, much faster than trying to type things out. You also don't have to remember the name of the path. If I have a typo, like this, and I hit tab, I keep hitting tab, nothing's happening. So if you don't get a completion, that's a signal that that file does not exist. Questions on this? Who's seen this before? Who's seen tab completion? Okay, pretty good, but not enough. Who's never seen tab completion? Who doesn't want to answer? Okay. Oh, some people answered. Okay. Very paradoxical. So yeah, if you remember anything from this class, tab completion will make everything much, much, much easier for you. It's not just for files. It's actually like customizable. You can write your own program and make your own completions. It's an entire built-in system into Bash. It'll work for command line arguments as well. So if you forget some ls command line argument, you can hit tab to tell you the command line argument. We're going to look at Git. It'll also work for Git as well, but I'll show that in a couple of weeks.
I'm scared.
You're scared of tab completion?
No. I'm worried about this time. It's so hard.
This time it's not going to be hard. Don't worry. Yeah. Oh, so dash that. So this is getting into the weeds on conventions of command line arguments, but dash and dash dash are used for specifying flags or arguments, inputs to the programs that are designed to change its behavior. But anyway, it's people who write these commands, like the Git, which we'll look at Git, the version control software. They'll write a script that'll tell, or write a specification file that'll tell Bash, here's all the things that you can complete in my tool. But I think we'll actually talk about that in a couple of weeks. So let's leave that aside. Just remember for now that for files, hitting tab, so for instance, if I don't type anything and I just hit tab, it's gonna warn me. I think there's a threshold for where it's gonna warn me. It'll print all of the possible options that you can type on the command line. It even works if you have an empty. Or actually, does it work on empty? It'll even work for commands themselves. So if I start typing C, for instance, it'll tell me all of the commands that start with C, and then I can, then they actually have a cd dot command. That's funny. So it'll help you explore your files, your commands, the arguments. It's a little kind of built-in, almost like built-in documentation or built-in help system, so that the command line is much less esoteric. It's not like a text adventure game where you have to guess the right command to say. Questions on this? Any questions on this? Yeah.
Can you alter the dot, or is that?
This is built into this is just hard-coded in the kernel, the operating system. You could probably rewrite it so it's not dot, but it's hard-coded at the kernel level.
I mean, so the dot that points to the parent, you can't alter so it points to something else?
No, this is managed. Yeah, you can't edit directories at all as a user. The files, they're managed by the kernel, by the operating system. Yeah. Yeah, I know. I see what you're saying. So I did. Well, okay. So the way using the commands that I showed you is I did cd ... to go to the parent. So in order to go back into the folder we were just in, you'd have to remember that we were in include and change directory back into that child directory. But there is another trick that I didn't put in the slides, where if you do cd space just hyphen by itself, it'll go to whatever the last directory you were in. So you can actually toggle between them. So for instance, if I'm in my home folder and I want to switch back and forth between my last folder and my current folder, I do cd dash, and it will do that. And now that's another little speed trick that I didn't put in these notes. But if you really want to go back to the last folder you were in and you don't remember what it was.
So if I want to go to CDNet, I go to CDNet, and if I want to go back to the phone, I go to CD dot.
So if I want to go to CDNet, I can go to the parent, which I know is CDNet. Well, so because CDNet is the parent folder. So if I do CDNet here, where is this relative path? What's the full path of net here? So my current path is here. If I say CDNet, which net am I referring to? Yeah.
So we're supposed to do all these commands like cd, pwd, and all of that and do it in no particular order or any order?
Well, I'll go over the homework. I will go over the homework, I promise you. I will go over the homework. So if I say CDNet here, and I'm currently in this directory, what path am I referring to? What's the absolute path of this net? Yeah, this is the same thing as saying cd this path here. So if I want to, so net is a parent folder. If I want to refer to the parent folder, I can use ... I could also just use the absolute path to the parent folder. This is the same as cd ... for my current directory. Does that answer your question? Sort of. Okay, I would just try it. Try following these commands on the from the notes, and hopefully that'll help. Also, the homework I think will also help. It'll kind of force you to use these commands, and you'll see the outcome. So let me review these real quick. Where am I? Print working directory. What's here? cd will change to a directory. And just remember from the first homework, there are relative paths and absolute paths. And so when you type anything here, this is a relative path relative to the working directory. So pwd showed me the working directory. If I put any path after cd or ls, you just glue whatever path you put to the working directory, and that's the path of the file. Does that make sense? No? All right, so I've got this hello folder here. I've got a folder called hello. If I say cd hello, you can construct the absolute path to this by taking the working directory, which I copied from here, and gluing whatever path I gave here. So you can always take a relative path, prefix it with your working directory, and that will tell you the absolute path of the file that you're operating on. So in this case, I'm changing my directory to this absolute path. Does that make a little more sense? So that's why understanding the file system, this hierarchical file system, relative absolute paths, it's like critical for being able to understand how to use the command line shell, because all these commands for operating on the file system abide by these conventions, these absolute and relative path conventions. Yeah.
Just to clarify, CD with no arguments just tells you what's directory, and then CD with an argument goes to the directory.
PWD tells you what directory, and CD without an argument takes you to the home directory. This is another kind of speed shortcut that I didn't put in the slides, but CD without a path at all. So here I'm in /user. CD without a path will bring you back to the home directory. That's just kind of a speed trick. You don't necessarily have to use it. You can always say CD tilde, or if you know the full path, you can put the full path. Questions on that? People are looking more confused than I expected, actually. But I'm glad we went through this. I'm glad I went at this level so you can see these commands. So we've only learned a few commands, but their depth is in the file system, like the file system tree and navigating the file system tree. So if you understand that file system tree and understand paths that point to different parts of the file system, understand the current working directory, it'll make using these commands much, much easier to deal with. Other questions? Questions on this? Yeah.
Sorry about asking, so I just confused about which two are equivalent to working directory.
Yeah, if I say these, for me, these are all equivalent commands. But I wouldn't worry about these too much. These are like other tricks that you don't really need right now. You can pick these up as you go. But somebody asked what happens if you do CD without an argument, and all these things are just defined by someone. These aren't like laws of nature. These are just conventions that somebody made up. Oh, right, it's a built-in command. Okay, other questions on what we've gone over so far? So this tab completion trick. Remember the tab completion trick. If you find yourself taking a lot of time typing out the names of files, especially in today's homework, use tab completion. It'll also confirm for you whether the file is there. So if you make a little typo, hitting tab will not produce anything. Even if you type the full path, once I hit tab and I put the full path in, well, actually, let's do a file. Once I put the full path in, it's going to put a space for me to tell me that I'm done. So if I hit tab, there's still value to hitting tab, even if you think you got the name right. Just hit tab, and it'll confirm for you whether the file's right. Yeah. List. Yeah. So ls is L. The L and the S from list. At least I think that's the case.
Thank you.
No problem. Okay. So make it a habit to hit tab. So I've also put in some there are some. So I would recommend going these on your own, looking at the notes, because this is like a lot to remember. But there are ways to edit your command line that are faster than just like using arrow keys. So if I made a mistake, so say I mistyped include, I don't have to sit and hit the arrow one at a time. I can use these shortcuts to jump around the command line. So this will jump basically by words, Alt B and F for forward and back. I can go to the beginning and the end of the command line, Control A and Control E, so you can think of A as like alpha, the beginning of the alphabet, E as end. So Control A and Control E will bounce me back and forth from home and end. I mean, it's the same as the home and end on your keyboard for most terminals. I can also delete more quickly with Alt, so Alt backspace will delete quickly. But I would just look at these, play with these as you feel comfortable. It's totally fine if you just want to use the arrow keys for now and home and end. So one thing that's important to remember here is no mouse. There'll be no mouse. Mouse won't help you on the command line to use this. It'll just send arbitrary, or not arbitrary, but it'll send sort of signals that won't be useful to editing any commands on your on Eustace. So yeah, just take a look at these. These are kind of like cheat sheets you can use. There's other commands like deleting a character, deleting whole words, moving forward and backwards. But I would just take a look at these as you feel comfortable. And this is more just reference material. You can also cut and paste. So I can cut and paste multiple times. Yeah, but I wouldn't worry about those too much right now. Okay, another useful feature, another kind of speed tip here, the kind of second most important thing to tab completion is rerunning commands. So if you find yourself crafting this really, like specially crafted command line and you go to build it, you get an error. All right, I better type it again. Let me spend a bunch of time typing this. And yeah, you can use tab completion to help you. But there's a faster way. Bash will record a history of all the commands you've ever run, or at least within a threshold. And so all you have to do is hit the up arrow or Control P, think previous. And Control P and Control N will allow you to navigate previous and next, allow you to navigate all the previous commands that you've run recently. So this long command, I just hit the up arrow once, and I don't have to retype the whole thing. So second thing, if you remember, forget everything from this class, tab completion and your bash history. Don't spend the time retyping really long commands, just use the up arrow to do this. Questions on this? Yeah.
The history saved, is it saved globally for whatever directory you're in, and you're running the command, or if you change directories?
It's saved per user. So there's a special file called bash history here. That file holds it.
So if you change directories and run other commands?
Yeah, for instance, if I change directories, my history is still the same here. And actually, you can if you type history, it'll print out the history of the commands that you wrote. So the last command is the bottom of the list, so you can think of this is like the list here. So as you hit the up arrow, you're going back in commands. It's like an append-only list of commands. So here's a little cheat sheet for navigating this command history. You can also search for previous commands. This is a feature I actually use a lot. You don't have to necessarily remember this. As you get comfortable, you can read over this. But I could search for prior calls to GCC, like when I was working on the projects for this. So Control R think of it as R for reverse search. You can search back in your command history for prior commands. But anyway, this is more advanced stuff. Don't worry about this. This is also another trick I use all the time. Let's say you're not ready to run a command. You can comment it out. There are comments in Bash, so this is just like scripting. So Control A to go back to the line, put a hash code there, hit enter. It won't get run. It's a comment. So then if you want to rerun it, you just hit the up arrow to go back to the command, remove that hash code, and then you can run it. Questions so far on this? Yeah.
So the command you run reads on your location. So how, like in relation to scripting, is it just kind of like read the line and run what's in there, or does it like script?
For the history or for Bash?
Yeah, it's just kind of like writing some script, or it's just running.
It's running them. It's running them interactively. But Bash is all the commands can be put into a file and run in batch mode as like a program. All right. So these are tools for viewing files. So cat is short for concatenate because you can view many files. This is how if you want to just look at text files on the command line, you can just write cat and print them out. More will help you look at large files. So if I want to look at, say, standard IO.header, which everyone probably has included before, you can see there's a little more % here. You just keep hitting space, and it'll just show you each page of the file one at a time. If you ran cat instead, it would just print out the whole file, and you'd have to like scroll back or something to view it. But more will show you one page full at a time. Less is more is the pun on this punly named command here. So this will allow you to like use arrow keys, move up, go up and down, page up and down, explore this whole file without having to rerun less again. So check out the notes for this. It has some slightly esoteric commands.
Right now.
Almost. We're almost there. We're almost at homework 3. Okay, so anyway, you can look at these commands for running less. The main thing is if you run this command, Q will escape. Q will quit. So it can't easily tell by looking at it. Q to quit. Okay, so this is what you'll need. So I'm starting to get to what you're going to need for homework. So for your homework, you'll use this command to download the homework. So you use wget, so you can actually download files from the command line. So you can just cut and paste it.
But I couldn't copy and paste it through my Chromebook. I had to manually type everything.
You can manually type it. You get good typing exercise. So it'll download the file for you.
Yeah, that's what I got.
This is a package file, so you can use tar to unpack it. It'll look something like this. And then how do I get into the homework 3 directory? CD for change directory. Let's make sure we're in the right place. Look at what's in here. Okay, so these are the commands for editing your file system that you'll need for homework. Yeah?
What's the command piece? Like in usage?
Oh, so this is your OS dependent. So there's nothing in the shell that'll let you paste, at least not without other tooling. Yeah. So on my system it's Control-Shift-V. On Windows you might have to right-click the mouse or something. What's that? Control-Shift-V. So yeah, for me it's Control-Shift-V. Mac it might be something different if you want to paste, but you can always type all these commands and it'll be good exercise to type them. Yeah.
What are the commands that are in the homework 3?
So this is like unzip. You can think of this as like unzip.
Okay.
So it's unpacking the file. Yeah. So I think I put a little explanation of these here. You can check the notes for explanation, but for the homework you can really just copy the instructions to get yourself this file tree. Okay, and so these are the instructions you'll need in order to do the homework. Yeah?
So this, like, when you have to create a new file, like, does it matter if it's like a page file?
So Touch will create a file. So Touch creates a file, an empty file. So for instance, when I run Touch, it just creates this new file here.
Like CAT? Like CAT?
No, it's Touch. It's a different command. So I just
No, but
created
it's the same thing.
Cat will print the contents of a file, whereas Touch will create a new file. So Touch creates a new file. So here I did Touch Paul, Touch Bob, and now I've got these additional files that I created in this tree. So that's how you can create new files. RM for remove will remove files. So you can see Bob is no longer here. Move will move or rename files. Remember, it's the same in the Unix world to move or rename files. So let's move Paul to new Paul. And you can see now this file has a new name. So these are what are actually like editing the directory file when you say remove or move. They're actually editing the directory file to add these entries or change these entries to the file or remove them. And then for directories, we have make directory. You can see here that my terminal color codes, or at least on Eustace, it color codes the subdirectories. But here's my subdirectory, and you can see that if I try to change directory to new Paul, it's not a directory. Touch will create regular files. If I do change directory to my subdir, I can do that. And remember to keep yourself oriented to where you are in the file system. So PWD and LS, keep yourself oriented. And finally, we have remove directory, like make directory. So remove my subdir. Yeah.
For the homework, are we submitting like the command to web courses or
In web courses. So all homeworks are submitted on web courses. Projects are submitted on Eustace.
How do I send the homework project on Eustace?
We'll go over that. We'll go over that in a couple of weeks.
Okay.
So homework. So remove directory only works if you have an empty directory. So you'll have to clear out the directory yourself, or there are other commands for doing that. Yeah, we had a question over here.
Yeah, I was going to say, does the make directory like produce a folder for Windows? You know what like directory you're at, and you go there, or does it file or will you see a folder?
In Windows, I'm not sure. I don't know. I don't remember the Windows commands for it. But on Eustace, if you do mkdir, you'll make a subdirectory. Okay, so let me go over. So I kind of quickly went over these commands. These are all the commands that you'll need for the homework. So let me go over the homework really quickly. Again here. So make sure you can get into Eustace. So sanity check your SSH setup. Run this command to download. Stay in your home folder. It's probably the easiest. Use wget. You can download the homework file from the course webpage. That's wget will allow you to download files from the internet. Actually scrape them if you want. tar will unpack the file and then start the homework by entering the homework directory, homework 3. So you can see here that we can look at the, let me remove this directory here and unpack it again. So you can run this command tree, which will show you the whole file tree in this nice little ASCII art. It'll show you the whole file tree. This is what we're starting with. And so the goal is to find a sequence of commands that will turn this file tree into this file tree. So let's take one example here. We've got fs ext2 acl.c. So there's two directories here in one file. And in my new file system, I have the same fs directory, but I have ext4 and acl.c. So these are the same, except the ext2 directory is now called the ext4 directory. So how can I make that happen? How can I change that directory name? Yeah. Okay, so we can use the move command. Okay, very good. So the move command takes two arguments. The first argument is the name of the old file. The second argument is the name of the new file. So which file am I moving here? Am I moving fs? Am I moving acl.c? Am I moving ext2? Which one is getting moved? ext2. So moving is just the same as renaming. It's just putting it in a different directory entry. So how do I refer to the first file?
You have to go to FS.
Okay, so there are a couple options here. You could go to fs. So that's one way. You could change directory to fs and do it here. That's one way. How could we do it without changing directory? Yeah, you could use the path to. Good, yeah. So what's the path to ext2 from my working directory? So remember, here's my working directory. Here's my tree. So how do I refer to this ext2? fs/ and actually you can use tab completion here to help you. fs/ and there's really only one file here, so fs/ext2. So voila, I've done it. I've referred to the ext2 folder. So now what is the name of the new folder, or what is the path to the new folder? fs/ext4. Yeah, you could put slash. Actually, I don't think it matters. So it looks like nothing happened, but if we look at the tree again, you'll see that now fs now has renamed this to ext4. Yeah.
what is the
Remove removes a file from the directory entry. Deleting it, but really just removing it from the directory entry. Yeah. I'm sorry, say again? you want me to show the steps of the homework again?
No, like I did the homework, but I don't know if it's clear. So like, how I made it. Like,
Oh, yeah, you could just do it over. Or, yeah, I mean, you could look in your history. You could run history and see if you can recover the commands as well. Yeah. Say again? So I'm sorry, say again? Yeah, these commands here, you can literally copy and paste it.
No, I mean like when I'm done with
Just save the sequence of commands. I mean, you don't even actually have to do it in Eustace. You could do it on paper as well. But just like, so one of the commands I ran to change the file tree is this. So just cut and paste that sequence of commands into web courses. Just say what the sequence of commands, and doesn't have to be exactly right. You could if it saves you time, you can say, well, move this path to this path. I just want to make sure you understand how to use these commands, and more importantly, understand how to refer to files in the directory tree, because that's really the key here. The commands themselves are very, very basic, and it's really all about getting the paths right, so that you turn one tree into another. So there's a little puzzle solving here. You need to look at the two trees and see what's different about them. So net here is empty, whereas here in the original file tree it had the Ethernet file or folder underneath, and that's not there anymore. So that's gone, but now there is a sound directory that wasn't here before. So you need to remove this directory and make this directory. So try it, and there's really only a few commands you need they're listed here. So if you can, so these are all the commands that you need in order to edit the file tree for this homework. So you just look at these and map each one to one of the changes that you need to do here, work out the paths, and then you'll get your list of commands. You can just literally cut and paste it into the box in web courses. It's just a text box. It's just text, so you don't need to upload a file or anything. Yeah.
The HID and the FS are switched. Is that something we also have to do?
Oh, so no. So the directories files and directories are unordered.
Okay.
There's no ordering on them. So sorry for the confusion on that. That happened because. So it's really just printing in the order that they were entered into the directory. So because I made this move or I did something, I don't know why I probably should have sorted them or something. But yeah, these are unordered sets of files. But yeah, that's a good question. Yeah.
If you did the wget link again, would revert back?
That's a good question. I would move your. Did I say this? So if you make a mistake and you want to try again, move your old folder. So use the move command to move it out of the way, and then just run tar again to unpack it again. I think that's probably the safest way to do it. All right, other questions? Hopefully it's not too confusing for you, but it's just, think of it as a little puzzle solving. You have a finite set of operations here. You have to know paths. You have to know how to refer to paths. And you've got a little puzzle here to figure out what's different and which command will help you make that difference. Yeah. It actually doesn't matter according to the tree. Yeah, so you could use either. Yeah. Nothing here tells you which one it is. So. All right, thanks all. Bye.